Okay, we're on the page ticket prices today. The objective today, students will be representing a functional relationship by various methods and analyzing the characteristics of those functions. Students will also create a table and graph of the function. Students will also be comparing and contrasting the characteristics of this function with previous functions in other lessons. All right, so those are some things that we're going to be looking at today in this one particular assignment. All right, on the ticket prices, up at the top, there's a couple of questions here, and we're going to work through here and see if we can answer some of these questions. Up at the top, it says, does the number of concert tickets sold depend on the price of the ticket? If one variable depends on another, can there be more than one dependent variable for each independent variable? In this exploration, you will further investigate the idea of dependence between two quantities and functional relations. Okay, so we're going to see if we can answer those questions when it's all said and done here. So here's the scenario we're dealing with, guys. We've got a popular band that they're scheduled to play at the amphitheater. However, the amphitheater management and the band cannot come to an agreement about the ticket price. They're trying to decide what should we charge people to come and see this concert. So this is the dilemma that we're having. So up at the top here it says, number one, the amphitheater has 50,000 seats. That's how many people they can fit into this place, 50,000. It says that as seen, they see a drop of 150 tickets sold for each dollar they increase the ticket price. The number of tickets sold can be calculated using the formula T equals 50,000 minus 150P, where T is going to represent the number of tickets sold, and P is going to represent the price per ticket. So I need you to circle a couple of things for me. First thing we're going to circle is what the T represents. The T represents the number of tickets sold. So circle that for me right here. T is the number of tickets sold. P, on the other hand, P represents something different. It represents the price per ticket. So T is the number of tickets. P is the price per ticket. That's what we're working with here. So you notice there's a table that we need to complete. And some of that table they've already kind of started for us. So if you look here, there's three columns. The first column is for the price per ticket. Over here, the middle is the process or the work that we're going to go through to get to the answer. And the answer we're looking for is the number of tickets sold. So the first one here, price per ticket. If we were to sell the tickets for $0, in other words, we're giving it away. It's for free. It's a free concert. Do you think we can pack the house and get 50,000 people to show up to the concert?
No.
Probably. Right? So that's what this is right over here. If it's a free concert, we're probably going to get a full house. We're going to get all 50,000 seats taken care of. But what if we charge $10 for every ticket? How many people do you think we're going to have show up to the concert? Well, in this case, it says that we're going to have 48,500 people show up to the concert if we sell the tickets for $10 a piece. And how exactly did I come up with that 48,500? Here it is. I did 50,000 minus 150 times 10. That's how I came up with 48,500. Let's keep going. What if I jack up the price to $20 a ticket? How many people are going to show up if I charge $20 a ticket? Well, let's find out here. We're going to do 50,000 minus 150 times 20. Now, you can put this in your calculator, guys. If you don't, if you can't do this by hand, we can use the calculator. Did we not grab a calculator?
No.
Okay.
No.
All right, I'll tell you what. This first row here, you're going to grab number 1, 2, 3, 4, and 5. This row right here, you're going to grab 6, 7, 8, 9, and 10. Then we'll do 11, 12, 13, 14, and 15. And then you'll grab 6.
No.
So quickly grab the calculator, and then let's find out what we get.
I'll wait right there.
All right, guys, hurry. Have a seat. Here's the nice thing about these calculators. You can type it in exactly like you see it, just like I have it written on the board with parentheses and everything. So let's go ahead and type in 50,000 minus 150. You can find the parentheses right above the number, I think it's 7 and 8. Right? Actually, it's above 8 and 9. The parentheses are right above the 8 and 9 button. So type it in just like I have it written on the board.
49,700.
What was that?
49,700.
No.
47,000.
There you go. 47,000. 47,000. In other words, if I were to sell the ticket for $20 a piece, we're expecting about 47,000 tickets to be sold. What if I jack up the price a little bit more here? What if I charge $30 for every ticket? Well, let's see here. Let's do 50,000 minus 150 times 30.
55,500.
Say that again.
45,500.
There you go. It's 45,000.
I can't say it right.
500. 45,500. So again, if we sell for $30 a piece, we're expecting about 45,500 people to show up to the concert. We raise the price even more. Now we're charging $40 a piece. So let's see how many people we're expecting to show up to this concert.
44,000.
44,000. 44,000. Raise the price even more. We're charging $50 now. So if we charge $50 for every ticket, we're probably expecting something like, what,
42,500.
42,500. And if we charge $60
41,000.
for every ticket, then we're expecting how many people?
41,000.
41,000. Anybody notice anything here?
Yeah,
What's happening?
Number
they're getting smaller.
What's getting smaller?
The number of tickets sold.
The number, and why are those number of tickets sold getting smaller?
Because the price is increasing.
Yeah, every time we raise the price, what's happening? Fewer and fewer people are going. Think about it, guys. If you were going to a concert and they were selling tickets for $1,200, are you going to go to that concert?
No.
Probably not. If they were charging $10 per ticket, the chances of you going are better than if they were charged $1,200. So, obviously, the more expensive the tickets are, the fewer people will go to the concert. Now, you'll notice down here at the bottom, we got one last thing to do. Notice that in our process column, all we did was replace what was in parentheses with the value that we were given for the price per ticket. This time, instead of giving me a number, they gave me the letter P. So I'm going to continue with this pattern. So I'm going to do 50,000 minus 150. And what exactly am I going to put in parentheses this time? The letter P. P representing the price per ticket. Of course, this right here, I cannot put in my calculator. We can't put this P in the calculator. But what we can do is we can multiply 150 times P. And when you multiply 150 times P, you just get a 150P. So write that down for me down in the bottom right-hand corner. It's 50,000 minus 150P. That thing right there should look familiar. Where have I seen this thing before? Look at that thing. Okay. Notice that thing that I have down there at the bottom is exactly the same thing that I have right here. So how did I figure out how many tickets were sold? Simply by doing this right here, where P represents the price per ticket. Okay, let's keep going.
No.
We're going to take this one step further. Now what we're going to do is we're going to take this table that we've just created, and we're going to create a scatter plot. So before we can do that, we've got to label some things here. The first thing we're going to label is the price in dollars along the x-axis, okay? So on the x-axis, we're going to label that as the price per ticket. So let's do that down here. This is going to be the price per ticket. Of course, this is in dollars. That's what the x values are going to represent. Price per ticket. The y values, on the other hand, the y values are going to be the number of tickets sold. So over here, my y's, that's going to be the number of tickets.
No cussing.
Oops. The number of tickets sold. My y values are the number of tickets sold. The x values are the price per ticket. Now notice there are no numbers on my graph here, so we're going to have to number it ourselves. However, if I count by ones, that's not really going to work for us, guys, because if you look at the table that we just got, we got some pretty big numbers. Let's start with the x's. Everybody look at the table that we just came up with. Let me go back to the table here. These right here are the x's, or in our case the p's. We had 0, 10, 20, 30, 40, 50, and 60. Obviously, if I count by ones, I'm not going to make it all the way to 60. So what do you think I should count by instead then? 10s. All right, let's go ahead and do that. So down here we're going to do 10, 20, 30, 40, 50, 60, 70, and 80.
Calm down.
So we're counting by 10s. The y values are even bigger. If you look at that table that we had,
Go by 10.
you'll notice that those y values, the biggest y value I had was 50,000. So obviously if I count by ones, I'm not going to make it all the way up to 50,000.
Go by 10,000.
10,000, all right, let's do 10,000. So we're going to do 10,000, which means the next one would be 20,000. Then we'll do 30,000. Then 40,000.
There, hit it.
50, 60, 70, and so on. So I had to adjust my scale to make sure that all these values that I came up with are actually going to fit on my graph paper. Now I've got my graph ready to go. Now we can start actually graphing each of these points. So the first order pair we started with was the order pair 0, 50,000. So that's the first dot we're going to put. 0, 50,000. There it is, right there. 0, 50,000. By the way, guys, I think my graph paper is a little bit bigger than yours, so if you didn't get all the way to 70,000 or whatever, that's okay. The next order pair was the order pair 10 and 48,500. So we're going to have to kind of estimate here. Here's my 10, but I'm going to have to estimate that 48,500. 48,500 is going to be somewhere up in this area here. And we're just kind of estimating here, guys. It's pretty close to 50,000.
It's just a line going kind of down.
Let me see. The next order pair was 20 and 47,000. So again, I'm just estimating here. We're talking somewhere right about in that area. 20 and 47,000. The next one is 30 and 45,500. So that's going to put it right in here.
Oh.
We're looking at the next one, 40 and 44,000. 40 and 44,000 is about right here. 50 and 42,500. A little bit lower. And then we had one more here, 60 and 41,000. 60 and 41,000, right about there. Anybody notice any kind of pattern here?
Yes,
Slightly down.
Why do you think it's going down?
The numbers are dropping. Going higher, I mean, I'm pretty sure people wouldn't be buying.
Well, that's right. What's happening is, as the price of the ticket increases, what's happening to the number of tickets sold? They are decreasing. They're going down, right? As this number gets bigger, this number over here is getting smaller, which we talked about the other day. All right, let's keep going here. Number 3. Number 3 says, how did you determine the number of tickets sold? Let me go back so you can see
Do we
what I'm
just put
saying.
that thing that she showed us?
All I'm asking you to graph this. Okay, so again, number 3 says, how did you determine the number of tickets sold? So let me come back to the table here. How did we come up with these numbers here? What exactly did we do?
We did that process.
We did this process right here. We always did the same process. So the question is, what is that process? Here's what I want you to write down for. And you don't have to write the whole thing. I'm going to shorten it, so make sure you listen up. All we did, and basically it's the first sentence, guys. All we did was I multiplied the number of tickets by 150. Actually, you know what? I think they messed up there. It should be I multiplied the price per ticket. I multiplied the price per ticket by 150. I multiplied the price per ticket by 150 and subtracted that answer from 50,000. And subtracted that answer from 50,000. That's all you have to write, just the first sentence. I multiplied the price per ticket by 150, and then we subtracted that from 50,000. That's all I need you to write down. Now let's go to number 4. Number 4 says that when we calculated the number of tickets sold, how many different answers did you get for each different ticket price? In this case, we only got one. We just got one. In other words, if I sold it for $10, we said it was going to be $48,500. And that was the only thing we got. If I charged $20, we were going to get $47,000. So we only got one answer. Number 5. How is your answer to question number 4 reflected in the graph? How is the answer to number 4 reflected on the graph? Here it is. On the graph, each ticket price, on the graph, each ticket price corresponds to one and only one point on the line representing the number of tickets sold. On the graph, each ticket price corresponds to one and only one point on the line represented by the number of tickets sold. Of course, the key part being here, one and only one. One and only one. So again, on the graph, each ticket price corresponds to one and only one point on the line represented by the number of tickets sold. Number 6, what are the independent and the dependent variables in the problem situation? First of all, independent. Is that the X or is that the Y? Independent is the, I think I heard it. Independent is the X, dependent is the Y. In other words, the Y value depends on the X. So let me go back to my table here real quick so you can see what I'm talking about here. Here's the table. What exactly were the Y values? What did they represent? They represented the number of tickets sold. What did the X values represent? They represented the price per ticket. So that's what we need to write down for our independent and our dependent. So here it is. Independent is the price per ticket. The dependent is the number of tickets sold. Price per ticket is the independent. Dependent is the number of tickets sold. I don't know if you guys remember, but last week when we did those strips where we had to match up and glue them onto our paper, I gave you an independent and dependent. You'll notice here how these match up. You'll notice that the number of tickets that are sold is going to depend. What does it depend on? It depends on the price. This one depends on this. How many tickets we sell is going to depend on the price of the ticket, right? Because if it's too expensive, are you going to get a lot of people to go to the concert if they're very expensive tickets? No. If they're very cheap tickets, you're going to get a lot of people showing up. So the number of tickets sold is going to depend on the price of the tickets. All right, next one. Does the situation represent discrete or continuous? Well, remember, discrete is individual points, dots that are not connected. Continuous means that the dots are connected. So what do we have here? Look at the graph. Look at the graph. What do we have? Are the dots connected or are they not connected? They're not connected. What do you call it when the dots are not connected? Discrete. Okay? It's discrete. Now, I'll let you shorten that, guys. All I need you to put down for me is that it's discrete because the points are not connected. And you'll notice here it says that we cannot connect those points because there is no such thing as buying a partial ticket. In other words, you can't go out and buy 2.5 tickets to a concert, can you? You can't go out and buy 10.5 tickets. Number eight. What happens to the number of tickets sold as the price increases? We've already said this. It decreases. As we jack up the price on the tickets, what's happening is the number of tickets we sell goes down. It decreases. And again, first sentence will suffice for the first part of the question. The number of tickets sold decreases. That's always going to happen each time we increase the price. Then it says, how is this reflected in the table and graph? In the table, the number of tickets sold gets smaller, and in the graph, the points on the line go down from left to right. So write that down. In the table, the number of tickets sold gets smaller, and in the graph, the points and the line go down from left to right.
Kathy Sanchez, if you're in the building, come to the AP's office, please, Kathy.
All right, guys, let me go ahead and move on. Let's take a look at number 9. On the next page, number 9, they're asking us to predict the price at which no tickets will be sold. So if you look at that table that we started, if we keep going along with that same pattern, at what point will no tickets be sold? What's the price here? In this case, it's
Wait, don't tell us.
$333. If I charge any more than $333 according to this table that we have, nobody will buy the tickets. It's too expensive. Might depend on who it is.
John Cena took it off his shirt.
Oh, yeah.
The what?
John Cena took it off his shirt.
Oh, no. No.
I
He
think
said,
that's
yep.
all it's worth.
All right, so $333. That's the price where nobody's going to buy any tickets anymore. Number 10. How did you determine the solution to question number 9? How exactly did I come up with this $333? Well, there's a couple of different ways. One of them is just following the pattern, right? Following the pattern. Students might repeatedly subtract 150 until the answer is 0. We could also divide 50,000 by 150 or extend the table and graph, which for us, that's probably what we're going to do. We're just going to extend the table or the graph. So that would be good enough, right? Just extend the table or graph. We just keep going with that same pattern over and over and over until we get to 0. Now, number 11, we kind of answered this one already. Number 11, they want to know, does the number of tickets sold depend on the price? How many tickets we sell? Is that going to depend on the price?
Yes.
Absolutely. Absolutely. Why is that? Well, because the more expensive those tickets are, the fewer tickets we're going to sell. Nobody wants to pay too much for a ticket to go see a concert. Alright, so number 11 is yes, changing the price, changes the number of tickets sold. The number of tickets sold can be determined by the formula or the pattern in the relation. Okay, we're going to do one more here. Last one, number 12. On number 12, they're asking is the price of tickets and the number of tickets we sell a relation? Let me remind you that a relation is a set of ordered pairs. That's a relation, a set of ordered pairs. So can I call this table that we have that has the price of the tickets and the number of tickets sold, can we call that a set of ordered pairs?
Yes.
Absolutely. Yes. Yes, this is a set of ordered pairs. Of course it is. Where is it? There's something. There it is. All right, so yes. Yes, this is a relation. Because the data in the table can be written as a set of ordered pairs. That's exactly what we're doing. We're creating some ordered pairs. Okay, guys, we're going to go ahead and stop right there. So once you get through getting all that down written on your notebooks, you can go ahead and put up your calculators. Make sure the calculators go back in the correct spot, and then make sure your notebooks get put up neatly.
Very good.
Johnny, get your notebook. When I get up, I choose my belly button.